This lesson concerns quadratic functions. We've already looked at the vertex form of a quadratic function. Now we want to look at the standard form of it. So let's take a look at just to review the vertex form. Just as a reminder, the vertex form of a quadratic is y equals a times the quantity x minus h, the quantity squared, plus k, where the vertex is h comma k. So it's the opposite of what's inside the parentheses, and it's the same as what's outside the parentheses. That's the vertex where we can start. Now when we build into the standard form, notice that it's not in the same form. The vertex will not stand out as much, so we'll have to calculate it. Now we do need to review a formula that you've used in the past, and we'll need to use at times when we work with quadratics. So this is just review. This is something that will be used in the future. Quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now you might wonder, where do those letters come from? They come from the standard form of the quadratic, which is y equals ax squared plus bx plus c. So when we see it in this form, we can pull out the a, the b, and the c and put it into the quadratic formula to solve if we have an equation, for instance, if it's equal to 0. Now, if you notice here, this form here, if this were equal to 0, we'd have an a of 1, a b of negative 16, and a c of 67. Now, let's go ahead and talk about how we can find this vertex hk when it's in this form. We'll need to use a little formula that's tied to information from the quadratic formula. If you look at the quadratic formula, this plus or minus, remember a quadratic has symmetry where you have the vertex, and then on both sides there's points on both sides, a plus side and a minus side from the axis of symmetry. Well, if we want to know just what the vertex form is, the x value for it, notice it's the opposite of b over 2a, because you have plus or minus 0 because it's right on the axis of symmetry. So to find the standard form, to find the vertex here, we want to make sure we just use x or h equals, which is the x value of this, the opposite of b over 2a. This is a critical formula now, again, a reduction of the quadratic formula where you don't have the symmetry. If you want to find the k value, find k by substituting in the h. Okay, so we'll see that. Let's do an example here. So for this here, when we work with this example, notice that my a is equal to 1, my b is equal to negative 16, and my c is equal to 67. So now when I've got those values, I can go ahead and find the vertex by saying that the h value for the vertex, just like the h value here in the vertex form, is going to be the opposite of b, so positive 16, over 2 times a, which is 2 times 1. So 16 over 2 is equal to 8. Now once we've got the x value for it, we can put that back into this equation and get what the y value is. So it's going to be 8 squared minus 16 times 8 plus 67. And that y value then would equal, when I do that calculation, I would get 3. So my vertex for this problem, using this example, my vertex is found at 8, 3. Now, so that's where we can center our graph. Remember, we use that as the axis of symmetry as x equals the 8. If you set up a table for it, the vertex should go right in the middle to represent the symmetry on both sides. So looking at this, once we get this axis of symmetry, a reminder is that that's x equals h. So for this example over here, it'd just be the axis of symmetry would be x equals 8. To find the min or max, remember that relates, the axis of symmetry relates to the x, the min or max relates to the y value. And when we have, if you recall, if we have A is positive, the graph then opens up. And when A is negative, it opens down. And so what we have here is when it opens up, we have a minimum. And so that would mean we'd have a minimum at k equals, y equals k at the vertex. So the k value at our vertex here. So, or if we had, if it opens down, we have a maximum at y equals k. So in this example, we would have a minimum, because it opens up, at y equals my 3 at the vertex. All right, and then lastly here, to find the y-intercept, what we want to do is go ahead and substitute in, x equals 0. So you put that into your formula, you'll get the y-intercept. So for this example here, we have y equals 0 squared minus 16 times 0 plus 67, which would just be equal to 67. That would be our y-intercept. In other words, it ends up being just the c value. So we have our standard form, the y-intercept is just c, y equals the c, whatever that last term is. All right, let's do a couple examples here. So first of all, let's pull out our a, b, and c. So our a here is just equal to 2, our b is negative 12, and our c is equal to 1. Our vertex then would be x equals the opposite of b over 2a, which in this case would be positive 12 over 2 times 2 is 4. That would reduce down to a 3. So my axis of symmetry would be, or my vertex value, x value would be 3. And what we then have for it is that would be our axis of symmetry, x equals 3. And we have to substitute it back in to get the y value. So 2 times 3 squared minus 12 times 3 plus 1. We do that calculation for this one. We get negative 17. So my vertex here would be 3 comma negative 17. So axis of symmetry is the x value. Since the a value is positive, it opens up. So I'm going to have a minimum at the y value there at the vertex, negative 17. And then the y-intercept, I put in 0 for each of those. I just get y equal to 1 is my y-intercept. Let's try this next one. If you were to graph that equation, if you were to put it into the graph, and if you need some reassurance on these values, you can put this into your graphing calculator. Draw the graph, you'll see the vertex, you'll see the axis of symmetry, and that the minimum's at y equals 17, negative 17. All right, so let's now do this next one. Notice on this one, my a value is negative 5. That means it's going to open down. My b value is negative 30. And my c value isn't listed, so it's a 0. So my vertex, I'll go x equals the opposite of b over 2a. So that's going to be the opposite of negative 30. It's going to be positive 30 over 2 times negative 5. So 30 over negative 10 is going to be negative 3 for my x value. Now I want to find the y value at my vertex. So I put in negative 3 here, so negative 5 times negative 3 squared minus 30 times negative 3. And that y value, when I calculate it, will be equal to 45. So my vertex is going to be negative 3 comma 45. I'd have to change my window a little bit to see that one. All right, now axis of symmetry is just the x value at the vertex. So x equals negative 3. That's the vertical line, the folding line that goes through the vertex. It's going to be a maximum because it opens down with a negative first coefficient, that a. So a max, and the max or min is always the y value at the vertex, so it'll be y equals 45 is my max. And then my y-intercept is whatever the c is out here, so my y-intercept will be y equals 0 for that. So that's an example of just doing the numbers. Now let's go ahead and look at some problems. Okay, this first quadratic problem that we're going to look at has to do with the height of a ball. So this is the equation of a ball that we would have, that we'd be able to graph if we want to put on our graphing calculator. If we want to know what the maximum height, what we have to do is find the vertex. And then we have the y value at the vertex. So let's pick out our a, which is negative 4.9, our b, which is equal to 19.6, and our c, which is equal to 5. So our t value in this case, since our variable is t, we're going to find the first value is t, the second value is h. But we're going to do our, first of all, our h at the vertex here. So I'll do my h value at the vertex is going to be the opposite of b, negative 19.6, over opposite of b over 2a, so 2 times negative 4.9. So when I do negative 19.6 over 2 times negative 4.9, I get 2. Now I want to find out what h of 2. H, again, this is a little bit confusing because h we had because of our h comma k. So this is a t value. Let me change that to a t. So it might make more sense for you to know that this is the t comma h value for these variables. T is my time, h is my height. So let's find the height here. So h of 2, by putting it into this h function, I'm going to put that in and go negative 4.9 times 2 squared plus 19.6 times 2 plus 5. And I get that y value to be, or in this case, h value, the height, to be 24.6. So the maximum height of the ball is 24.6. Okay, if you were to look at just a quick sketch, let me just draw this just so you see it. What happens, the y-intercept is a 5, and this graph goes, the ball goes up like this and then comes down and hits the ground. I'm looking at this maximum height here. That's at a time of 2, it gets the maximum height, and that maximum height is 24.6 for it. All right, let's do our second example here. This example is actually finding the formula for a parabola that passes through these points. We don't know what the a, b, and c are for this, so I'm going to list this a little bit different than normal. I'm going to make this ax squared plus bx plus c, and I'm going to make it equal to y because this setup will be helpful for using Cramer's rule. So we're going to actually apply Cramer's rule to this. So what we'll do for this is we'll put in the ordered pair 2 comma negative 8, and if I put that in, I'm going to put that in for all the x's. So I'm going to have a times 2 squared, which is 4, plus b times 2 plus c is going to equal my y, which is negative 8. So in essence, I've got 4a plus 2b plus c equals 8. Okay? All right. So now when I do that, Now I'm going to do the same thing with 8 and 4. I'm going to put in 8 for my x here, so I'm going to have a times 64 plus b times just 8 plus just a c, because there's no x in that one, equals my 4 as my y value. And so that equation is going to be 64a plus 8b plus c equals 4. And then my last equation, I'm going to put in 10 and 24. So a times 10 squared is 100, plus b times just the x, which is 10, plus c, and that's going to equal my 24. So I've got here 100a plus 10b plus c equals 24. Now notice this is a system of 3 equations with 3 variables. Here my variables are a, b, and c. I can use Kramer's rule to go ahead and solve this. Let's take a look at what that would look like. So if I were to use Kramer's rule on this, let's go ahead and set up the first coefficient matrix. Now instead of using c, because c is one of my variables, I'm going to call my coefficient matrix f, just to make something different. F is in coefficient, and so I use that as my coefficient matrix since c is one of my variables. So I've got my coefficient matrix is going to be 4, 2, and 1, 64, 8, and 1, and then 100, 10, and 1. Just double check my coefficient matrix there. All right, and now if I were to do that on my calculator, I'd go ahead and find that determinant. I would get this to be equal to negative 96. Let's do our next matrix. Let's call it the A matrix here, where I take out the A coefficients here, and I'm going to replace it with the constants 8, 4, and 24. And for this should be a negative 8, okay, for my value there. And so this will be a negative 8 here. Okay, so I replace that with a negative 8, 4, and 24, and then just list these as is: 2, 8, and 10, 1, 1, and 1. All right, double check that just to make sure you've got it listed correctly. And then when I do that determinant, I also get negative 96 for that. Let's try that again. And now let's do the matrix for B. And that's going to be where I take and I leave the 4, 64. Let's do that again. 4, 64, and also the 100. And then I replace the B coefficients with the constants, which are going to be negative 8, 4, and 24. And then leave the C coefficients alone. All right, now when I double check that one just to make sure. Okay, and then when I do that on my calculator, I get 768. And then when I do my C coefficient, my C matrix determinant, I'm going to leave the first column alone, 4, 64, and 100. Leave the second one alone, 2, 8, and 10. And then replace these numbers, the constants, negative 8, 4, and 24 into the C coefficients. And when I do that one, double check it just to make sure. When I do that one on my calculator, I calculate that to be negative 384. So now I've got these values, I can figure out what A is. A is equal to the A coefficient, -96 over -96. That gives me a +1. My B is going to equal the B1's 768 over -96. And when I calculate that out to be, I get -8. And then my C is going to be equal to this coefficient, or this determinant, -384 over -96. And when I calculate that one out, I get that to be 4. So what I've got is my A, B, and C in this form. So I can just substitute those in now. I'm gonna have 1x squared plus or minus 8x for my B, and then plus 4, my C, equals y. There's my quadratic from using this information. And you can go ahead and check those if you want to. Check the ordered pairs for this. This one was the 1024 that went to this one. So check these 3 ordered pairs if you'd like to in that, and you'll see that those all fit. So we've learned the standard form of a quadratic. We've learned how to get the vertex from that, also the axis of symmetry, also find out what the min or max is, and also look at the y-intercept. And then we've applied it to some different problems to solve. And we can use this information now to work with quadratics and solve many of the quadratic problems.